Okay, so here we have the question 2 says, hence determine the values of t for which the equation x plus t squared plus 6x plus t plus 5 is equals to minus x plus t minus 5. Find the values of t for which this equation has one positive and one negative root. In the previous question, we realized that the roots for the equation without any shifts would be x plus 5 and x plus 2. So those are the roots of our equation. And if you were to draw them out, it would look something like this. And that would be minus 5 and that would be minus 2. Then for our problem, we are tasked with finding the values of t, which is basically a shift along the horizontal, where we can shift this graph such that one of these points is lying to the right. So if I were to, let me see if I can move it alone. Okay, it's quite difficult, but we're looking to move this such that it satisfies this kind of condition, that we always have one root on the left hand side, which means an x-intercept, and one on the other side of the x out of the y-axis. So that is what it means to have one positive and one negative root. So in order for that to happen, we're basically saying that this t, which is the shift, should move by a value that is less than minus 2. So t, we can say it should be less than minus 2, but it should be greater than minus 5. And it may get confusing because we're dealing with greater signs and we're dealing with negatives. So when you think t greater than minus 5, you might think minus 6 and minus 7, but no, minus 6 and minus 7 are less than minus 5. So we are saying that we can move this bar over here by any value that is less than, that is greater than minus 5. So that can be minus 5, minus 4, minus 3. But then we're saying that it has to be less than minus 2. So minus 2 is the greatest shift that it can have. Or, yeah, it's the smallest shift, but it's the greatest negative number that we can have it be. So t has to be less than minus 2, or it has to be greater than minus 5, meaning we can move this point, should never reach the x-axis at this point, because that wouldn't satisfy our condition. It should always be strictly less than that point there. So that's the region we are describing basically. See, let me just erase this. Cool. We're saying our graph should always be in between. One arm should be on the positive side, one arm should be on the negative side. So if you compute those lengths, you will get this answer, that t should be in between minus 2 and minus 5. So it should move at least 2 units to the right in order for this one to reach the right hand side. But if we move it by any value that is smaller than minus 5, it will end up all the way on the other side, giving us two positive roots, which is something we don't want. But yeah, I think that's enough elaboration on the answer.